Domain and range is a common topic in functions. Obviously, you can't go on with functions without describing domain and range. And students seem to always get confused about what is domain, what is range, how do we find them, how do we talk about them. So before this, make sure that you've seen the video on set notation or interval notation so that you're able to describe domain and range in an effective way. So the domain of the function is all the values of the independent variable, which we commonly say is x. And the range of the function is all the possible values of the dependent variable, which we commonly use y for. So basically what it means is the domain is the input and the range is the output. Another way to say it is the domain is all the values you're allowed to put in your function. Now you will be facing some functions where there are certain values you're not allowed to put in. For example, if you have 1 over x, then x equals to 0 is something that you're not allowed to do. So 0 will not be in the domain. We talk about domain as the values that go into the function or the input. However, it's actually best to think of the domain or to describe the domain by first thinking of all the values you're not allowed to put in there, and then you describe the domain excluding those values you're not allowed to put in there. The range then comes intuitively or with more practice or by seeing a graph. So with more practice, this video is going to be just a basic explanation on domain and range, but for more specific functions like reciprocals, you'll have to study their domain and range more specifically. Now, the domain is the input, so it's the x value. So what you're going to do is, if you're given a graph, you're going to scan the graph from left to right or from right to left. It doesn't matter as long as you're looking at the x value. So we've scanned through and I'm trying to see where do my x values appear. So I can see that 6 didn't appear in my scan. There's nothing here for 6. I can see something for 5, -5, -4, -3, and so on. I can see that happening. The range is looking at the y. So you're going to scan the y, you're going to go from up to down, and you can see the range or the output. And as you can see, 7 and 6, there's nothing that appears here. But then from 5, you have something that appears, 4, 3, 2, 1. So they touch, there's a curve for those values. There's a coordinate for those values. So one thing to note, if it's a closed circle like this one in here, remember the pink is our curve, not the green and blue. If it's a closed circle, it means it's included, so you have to use the closed brackets, the curved brackets. And if it's an open circle, it means it's not included, so you use the square brackets. And if there's an arrow on your graph, on your curve, like this pink one at the end, then it means that your value goes to infinity. So take a few minutes, think about this graph. So using set notation, I can see that the domain, the input, starts from -5 and it goes all the way to the end. It doesn't really stop. The graph just continues, and if I extend this x-axis, I could still see some values being plotted for this curve because it goes to infinity. Again, always think horizontal and try to see if you're getting coordinates. So precisely my domain is when x is bigger than or equal to -5. So it starts from -5 and it goes over. Or you can say it goes from -5 to infinity, and that's all because we've scanned the graph. So again, if you look at this, I'm scanning, I'm starting from -5 and I could go all the way to infinity. And then the range, if you're scanning it, you'd see that it starts from 5 and it goes all the way to -infinity. It means that y is less than or equal to 5. Or you can say that it starts from -infinity and it goes to 5. Remember, we always start lowest to highest with the set notation. So make sure that you're scanning the domain and range properly. It's much easier to see the domain and range using a graph, so that's your first intuition when you're starting domain and range, and then slowly shift to actually understanding what domain and range to pick for more complex functions like reciprocals and rational functions. Now, there are different ways to state the domain and range. If I have a table of values, again, my domain is my input. It's my independent variable. So my domain will be 2, 5, 7, and 9, that first row. And my range is the output, so 3, 1, 5, and 5. Now, for set notation, we don't repeat values, so I don't need to write 5 twice. So if it's a table of values, that's just your input, that's your output. It means that's the domain and that's the range. If you have a mapping diagram, again, where you start your mapping, that's your input. So you have -3, -2, 5, and 7. Notice how we're using curly brackets to denote set notation. And then the range is just the output, whatever you get, 4, 6, and 8. Now, if your mapping includes an additional number, like 9, that doesn't get mapped to, it means that it's not within your range. It means that none of the inputs are giving you this output, so you don't include it in your range. So range is actually whatever your function inputs. If my function is not inputting a 9, then it's not part of my range. If you have a set of ordered pairs, remember that they have a specific order, like coordinates, so x, y, x, y, x, and y. It means the first value is my domain, so -3, -1, and 3, and my second value is the range, so 5, 9, and 5. Again, we don't repeat the values. Also notice that we tend to write values in a set notation from smallest to largest, but that's by preference, it's not compulsory. Another form is an equation. So if you look at this, if you stare at it a bit more, remember what I said about domain. It's a bit hard to specify what the domain is. You're like, okay, it just feels like all the values in here. Well, it's true. With equations, if you're just given an equation, my advice is to first think, is there a value I'm not allowed to put in there? If there is, then you remove it from your domain. So first assume that the domain is all the real numbers. Just start with that. The domain is all the real numbers. And then look at the equation again and see, or the function again and see, is there a restriction in here? As you can see with this, it's a linear function. There's no restriction. It means that my domain is just the set of all real numbers. I can use the negative infinity to infinity notation. The range for a linear function, and you might have to know the range more specifically for each type of function. The range for a linear function is just the real numbers, so y belongs to the real numbers. And this again comes with being exposed to as many functions and equations as possible and knowing their graphs. That would be very helpful for the range. The domain, again, my advice is to look at if there's a restriction. And then you have a discrete graph. So it's a graph that doesn't have like a continuous curve. So your domain is basically remember you're scanning the x-axis. So -3 doesn't have an output. -2 does. So -2 is part of my domain. -1 does. So -1 is part of my domain. 0 does. 1 does not. 2 does. And 3 does. So I'm just going to put all of these in here. And then the range are all the values that actually have an output. So if I'm scanning the y-axis now, let me look at the y-axis. Let me start from the bottom. I can see -6 in here. I can see -2 appearing 3 times, but I'm just going to write it once. And then I can see 3 in here. So this is my range. So hopefully this was clear. It's just a basic introduction to domain and range, and just take my immediate advice about domain, about thinking that the domain is all of the real numbers unless you have restrictions. But if you have things like discrete graph, a set of ordered pairs, mapping, and table values, it's obvious what domain and range is. But later on, when you're exposed to more equations, just think of the domain like I explained it. And then make sure you write them in set notation, so in a formal way. So either using set notation or interval notation.